Okay, hi everyone. Welcome back to my YouTube channel. And as usual, I am hosting Raji for the third part of our Amazon Bedrock series. So I hope you enjoy. Not talking much today. I let Raji do the introduction of what you're going to discuss today. Yeah, don't forget to like, subscribe, share when you can, and I hope you have a nice learning experience. So, yay, over to you, Raji. What are you doing today?
Thank you,
Okay.
Pauline. It's always great to be in your YouTube channel. Today, we are going to talk about AI agents, and this is going to be part three. So, in the earlier series, we got introduced to Gen AI, and we saw how to use models in Amazon Bedrock. And last week, we spoke about vendor embeddings and RAG-based architecture. So today we are going to see AI agents. And before we get into AI agents, I just want to take few seconds on talking about an interesting concept called artificial general intelligence. So as we are advancing in AI, we are trying to create systems which are more human-like. So now the AI systems which have capability to perform specific tasks. It's also called narrow AI. Now, what artificial general intelligence is about is it's a type of AI which has the ability to understand. It has the ability to learn and apply knowledge across a wide range of tasks, more like humans. So here in AGI, which is artificial general intelligence, you will see certain features like versatility. So here AI systems can handle various types of tasks, from problem solving to creative thinking. It will have a learning capability. It can learn new concepts and tasks in real time. And more importantly, it will be more autonomous. So far in the last 2 weeks where we saw the AI models will follow our instruction, and it will not decide for by itself. Now, AGI is about creating AI systems which are more autonomous, which can make decisions, they can do a reasoning, and they can function independently. So that's a new evolving concept, and this is more like the next step. So here AI systems, since they don't have the capability to do reasoning and problem solving, we are addressing this with AGI. And before we get on to it, I just wanted to also highlight about an interesting book called Thinking Fast and Slow. So this talks about the kind of reasoning or the kind of decision making or the way in which AI systems think. This has been broadly classified as System 1 and System 2 type of thinking. This actually comes from psychology, and it is used to describe two modes of human thinking. And when this is applied to AI systems, this framework, it helps us to explain how different types of AI function can be designed in the future or might be designed in the future. So system one thinking, it is more faster, it is intuitive, it is automatic. So here AI systems will operate quickly. They are trained on large data sets to recognize patterns. They will provide solutions or some responses, but they will not do any in-depth analysis. So it's more rule based. It's more instruction based, and but it is faster. The other type of thinking is system two. It is slow. but it is analytical. It has more deliberation. So this is the one which will mimic the human way of thinking. So it will have reasoning. It will help you to solve unfamiliar problems. It will apply logic. It will do abstract thinking. It will look around knowledge sources, and it's more kind of a human way of thinking, but it is slow. So what we are trying to do as we advance is we are trying to create systems which are more system 2 type of thinking. Now, AI agents is one such example where we are bringing in autonomous decision making, and try to make the AI systems more independent. So the main features or the main components of AI systems is the ability to plan. They have ability to interact with various tools. So you don't have to tell the agent go and look at a database or check the PDF. That's something which you won't tell. It will have the capability to find out which tool to get in touch with. And it has memory, and it can execute actions independently. So that's about AI agents. Now, since we are talking about the capability that AWS has in Gen AI, we are going to focus on AI agents in Amazon Bedrock. The Amazon Bedrock has a specific capability around AI agents where you can create, where you can configure. So that's what we are going to look at today.
Okay. Thank you, Raji. Just before you get into that, maybe I can ask a question. So you mentioned more focus on the system two, a
Yeah,
bit of it. So
yeah.
my first question will be, are there, for example, any AI agents that are using system one, or this is something which is in development or not possible?
No, system one is there. System one
Mm-hmm.
systems are faster and they require less effort. So it is to do something like a familiar task, right? So system one are the general
Okay.
foundation models which we saw last week.
Yeah.
System two
Oh,
is something which will be slower, but they will have reasoning. So system two is more advanced, and system one is more like a rule based.
oh, okay, cool.
Yeah.
Thank you. And also, we are talking about maybe AI agents, for example, in AWS. Like,
Mhm.
what are other maybe types of AI agents for maybe people who are not into AWS? Some examples. Might you know some examples from maybe other providers, or what is available out here?
Yeah, there are lots actually. Chat GPT is
Mm-hmm.
an AI agent,
Okay.
and Bard from Google, that is an AI agent,
Mm-hmm.
and there is Alexa, which is a virtual assistant. That is technically a voice controlled AI agent. Then there is Midjourney. Midjourney, it's a generative AI uh, platform where it creates artwork, right, from textual prompts. So that's an AI agent. And in NVIDIA, there is Omniverse. So that's also an example of an agent. Yeah, so there are many, and it's an evolving space. There are
Okay.
different types of AI agents as well, model based, goal based, utility based, learning agents, and so on. We should have another series on this as we move along.
Amazing. Okay, thank you so much. We can carry on.
Yeah. Okay. So yes, so we were talking about how AI agents are in Bedrock. Now there are a lot of features which you will see in Bedrock AI agents. So like other agents, they use LLM behind the scene to understand what we are asking it, and they use LLM to give response back in natural language. And any task that we give them, it will divide the task, it will break the task into subtasks, and it will complete these tasks automatically. And the way it would complete is during the task execution, it can go to a number of systems, tools, and it will execute. So we don't have to tell the agent when and where to go. And of course, it's more secure. And you can give an enterprise data to an agent and it will not compromise the privacy. And while it's executing the task and by the time it gives you a response, you also have a capability where you can trace. You can see what was the thought process or what was the decision behind behind executing the various subtasks. So that is enough visibility as well. So if we go back here, you can see these advanced prompts here, right? So this is where you can see the stages. So pre-processing is where the prompts are categorized into various categories. So this is the default prompt template. So category A is the agent will know whether the prompt is malicious or it is harmful. If so, it will categorize it as A. And C is where the prompts are such that the agent is not able to give any response using the tools that we have defined. D is something can be answered by the agent, but using only the tools that we have given or the functions it has been provided. So this is something where the tools are able to answer or they can cater to the prompts. Category E is prompts which are not questions but are answers to a previous question. So this is the first task which the agent will do. It will first categorize into one of these buckets and accordingly it will handle. So next it goes to the orchestration phase. So here this is where it will categorize the prompt. So based on the prompt, it will use the necessary tools which are essentially the functions. So each of the tool is put inside a function and it will have a specific guideline. And next is the knowledge base. So if there are any knowledge base which we have added, it will accordingly call the knowledge base and it will search. And finally is the post processing. So here is where the response is formed, right? So this is the template. Now, the reason why I'm showing you is I need to understand the different stages in which the prompt is parsed, and the capability to customize these templates is something which is a very helpful feature in Bedrock. Another one which I also want to highlight is if we want a completely customized behavior, there is also a possibility to write a custom Lambda parser function. So this is an advanced capability where we completely override whatever is the default behavior pattern when you give a prompt. So we can decide what should happen when category A is called or B is called on. If we want to bring in any sort of customization, we can independently do, and that's possible using custom parser Lambda functions. We should also see about this in the forthcoming or in the future series. is Maya. So Maya is someone who is owning a grocery store. So she just started her grocery store and the business is going on well. But as the business is booming, she is also coming up with new challenges. Like she is meeting new challenges. So what is happening is, as she is expanding her business, she is having a difficulty in tracking the expiry dates of the various grocery items. So she is concerned about product being spoiled. She starts getting customer complaints, and she also faces challenges in managing stocks. And also very important is her staff is not able to maintain sanitation standards and hygiene standards. So she has this fear of an audit. So all the grocery stores undergo an audit by the Food Safety Authority. So she has this fear whether she will clear this audit, or if her business reputation will be on stake. So she is looking for a better way to manage the food safety, to manage the stock, and how she can keep up with the hygiene best practices without much manual or monitoring effort. Now she already has been using AWS for her retail grocery website. So she comes across Bedrock. So she gets introduced to Bedrock, and she decides to use uh, Bedrock, where she is able to create agents to manage these complex tasks. She decides to use the agent natural language capabilities and action groups. So what she essentially decides is, she has a lot of food safety manuals, which are huge PDFs. So she decides to use them as the knowledge base. She also has a database where she maintains the inventory of her grocery items, as to what is their stock, when are they getting expired, and so on. And she has that's something which is local to her, and she maintains it in her database. And now she plans to use that in her action group, and this would help her to know both ensure that she adheres to the standards, and also it also helps her to bring some context. So she is using both the external knowledge, which is the food safety handbook, and also her enterprise, her local database. So she is able to orchestrate between these two with agents. And what we are going to do now is we are going to create this agent for Maya with these PDFs and the action group. All right. We are going to create an agent for Maya now. So we'll say create agent. I'm going to name this agent as Maya agent. Okay, so you give us description, which is an optional, and then you can create a new service role or use an existing service role. I will go ahead for creating a new service role, and this is where you give instructions. So there is a lot of customization, specific instructions which you can bring in here. For now, I'm just going to give us a very simple instruction. You are a grocery store agent to help users refer documents for safety standards and manage their inventory. You are polite and obedient. So this is a plain natural language English. Okay, so I'm not going to have memory. If you want a memory, then you can change the model here and accordingly select a model which supports memory. And then here comes the action group, right? So here, as we saw, Maya needs to check her database, her enterprise database, where she is maintaining the inventory details of her grocery items. And then comes the knowledge base. So, which is what I'm going to bring in the agent. So let me show you the table where she's maintaining the inventory. So there is already a table which is the enterprise knowledge or which is the contextual knowledge. All right. So it's called the grocery store food safety stock management. So this is the table which I have already created. So this is going to be your enterprise data. So if you look at here, so if you look here, you will have all the grocery items and few metadata about these items. Okay, storage temperature, supplier, then stock level, expiry date, and so on. So in this action group, what I'm going to do is, so let me give a name for this action group. And I have to select define with APIs schemas because I'm going to use a Lambda function which will query this DynamoDB whenever there are queries related to inventory. So I select define with API schemas and I should select an existing Lambda function because I've already written the Lambda function. So let me show you the Lambda function. So this Lambda function essentially has all the methods. So it has a method to check the inventory. Let me maximize the window. So it has the method to check inventory, right? So it will just scan the entire table. I have a method to check products which are near the expiry date. So if I give a prompt which says about get me the products which are near expiry date, so it will invoke this function. I also created a function to get products from a specific supplier. And then comes the main handler where depending on the API path. So we are going to have a JSON which is the OpenAPI schema. So if you see here, you give the Lambda function and then you have the action group schema, right? So in this API schema, so this API schema is nothing but an open API schema where you will define the APIs, the different APIs for different methods. So that's how you have the linkage between the API and the Lambda function. So each of these methods will have a corresponding API in our schema. Okay, so this is the entire code. So it's a very simple code. All you need to do is in your main function, you handle the APIs. You basically map the APIs with the methods which you have already defined. So let me show you the API schema as well. So this is the JSON. So this is the OpenAPI schema. So there is a specific structure to it, and you just give the title and description, and then the path. So under the path is where you give the API path. So inventory, check expiry, and supplier. So each of this has a corresponding Lambda method, right? So in the Lambda main handler, you will check what is the path, and accordingly you will map the method within the Lambda function. So I hope that is clear. So we'll go back to the Bedrock screen. So here we will just bring in our Lambda function and the OpenAPI schema. So Lambda function is agent status checker. And this is the URL of the JSON. So that's all about it. You bring in the Lambda and the OpenAPI schema. Then you create. Okay, so you should always save the agent and then create. So that's why you are getting that message. Define with API schema existing Lambda function. Okay, so it's getting created. So as I said, when you create the agent new, give the name, give the instructions, save it, and then you bring in the action group. So our action group is set now. Now we have to bring in the knowledge base. So Maya needs to refer to the food safety standards, which she is maintaining in PDF documents. So I already created a knowledge base where these documents are linked as a data source. So let me show you that knowledge base before I bring it in here so that you follow what I'm saying. So I have a knowledge base called Retail Store Assistant. So here, this is connected with a S3 bucket, which has a bunch of PDF documents. So this has all the manuals and the safety, the guidelines which are needed by Maya. So I have a bunch of four, some are handbooks, some are manuals. So these are, I just downloaded from net, which are related to grocery store, and they talk about all the food safety guidelines. So I created a S3 bucket and created a knowledge base out of it. Now I'm going to bring this knowledge base into the agent. So it's very simple. You just add and choose the knowledge base, Retail Store Assistant, and then add. So once you add this knowledge base, you save and then you prepare. So another important point to note is after you save and before you are, I mean, once you are done with all the configurations, you save and then you have to click prepare. So only if you prepare the agent, it will be ready with all the configurations that you have saved. Okay. Okay, in instruction, yes. So instruction has to be given here. So if you remember, earlier I did not save, so I had to do all over again. So when I did again, I missed to give the instruction. Agent. Save and prepare. Okay, agent was successfully updated. Agent Maya agent was successfully prepared. So that's all about it. We are not going to touch guardrails, and these are the advanced prompts. So we are not going to look at it right now. Now let's go ahead and test our agent. Okay, so let me show you the PDFs so that you have an idea what kind of data it has, and accordingly we'll give the instructions. There is a PDF which talks about food safety. So it has guidelines and manuals about how food has to be packed, and what are the hygiene standards and so on. Then I have a manual um, which talks about the guidelines for setting up retail stores, and then I also have some grocery a list, and it has some statistics. So this is the PDFs which are behind the knowledge base. So I'm going back to the Bedrock and I'm going to give some prompts. Okay, what are the food safety guidelines for frozen food? So this is a prompt which will be met by the knowledge base. Okay? We are not telling the agent that it has to check the knowledge base. The agent itself will know which tool to use. So for the agent, the action groups and the knowledge base, they are the tools. So if you see here, it has searched the knowledge base and it is giving an answer that it should be minus 18 degrees Celsius. So let's see the various path, the prompt, or the various stages in which the prompt has been traversed. So you go to show trace, and then here and the pre-processing trace, you have trace step 1. So if you see here, these are the configurations for model invocation. Again, if you want, you can make it more creative. If you remember in the very first series, we saw top K, top P, and so on. So this is the standard text. So here, if you look at it, it talks about categorizing the prompt into various buckets. So we saw category A, B, C, right? So that's what happens as a first step. Okay, and then comes the tools. All right, so these are the action groups. So our schema, if you remember, we had APIs for checking inventory. So that's what it is. It has listed down here. So this is a standard text. So you can see category A, category B, category C, and so on. So here comes the output. So it is taken our prompt, food safety guidelines, and it is trying to see which tool to invoke. So before that, it has to categorize, right? So here the user's input is talking about food safety guidelines. This seems to be a reasonable question, which means it is saying that it is a valid input. So if you remember here, um, is valid input. So it uses the LLM and it checks whether it is a valid input. So here it says it's talking about food safety guidelines, and this seems to be a reasonable query. So it has validated that it is not malicious. It's a genuine prompt, and it has categorized the prompt as category D. Okay, so category D is a question that can potentially be answered by the function calling agent using the provided function. So there are a set of tools or functions which we configured, and it has decided that it is the prompt is a D category, and it can be met or answered by the tools that we define. So it goes to the orchestration stage, where there are steps from 2, 3, and 4. So let's see what happened in step 2. So the same thing that you saw earlier. So here in the orchestration, it is reaching out to the knowledge base. Right, so it understands that this is a prompt which can only be met by the knowledge base. So it gets into the orchestration. So here, coming back to our diagram, so it's reached here. So this is where it gets into the orchestration stage, and it searches the knowledge base accordingly, which we have configured, and it goes to the exact knowledge base. This is the ID, unique ID of our grocery store knowledge base, and it takes the prompt that we gave, and it is searching the knowledge base, and this is the search result, and this is the location, the exact PDF that it has searched. So it's getting this raw text, and then it gives the final output. So it is doing a post-processing exercise. So it's searching all the relevant location. So this is all it has searched. So this is the first step. So it goes around all the relevant PDFs. And then in the third step, here again, it's doing some orchestration. Yeah, so here it does the final, it gives the final response. So in step 2 and 3, we saw where all, I mean, what are the various PDFs it's going through. And in the fourth step, it gives the final response. Okay, and then comes the post-processing. So, I mean, there is nothing to post-process here. We did not give any specific instruction. So it searches all the knowledge base, it forms the final response and gives back to us. All right, so that's about how the various stages or the stages in which the prompt is taken through by the agent. Now let's give a prompt which is something got to do with the table. So if you remember, we created an action group which has a Lambda function, right? So this Lambda function, which takes the OpenAPI schema and checks the DynamoDB. So let's give a prompt which will, make the agent to reach out to the DynamoDB. I'm going to give a prompt which will say, get me the food items which are nearing expiry date. So let's see how it's behaving. Okay, so if you see here, it's bringing from the table, right? This time it's not from the knowledge base. So if you refer our DynamoDB table, so it says fresh milk is expiring on October 2nd October. So here, fresh milk, where is it? Where is fresh milk? I think it's here. Yeah, product name is fresh milk. Yeah, so fresh milk, which is beverages, the expiry date is October 2nd, right? Then almond milk, butter, chicken. So these are the items which are expiring. So let me sort it out, sort the expiry date. Yeah. So all of these items are near expiry date. Now we defined a Lambda function to get items which are nearing expiry date. So it has ideally called this function, and how it has called is with the OpenAPI schema, right? So let's see the tracing so that we better understand the path that it has taken. So if you say show trace, pre-processing. So these are the general instructions. So here, pre-processing, what the agent has done is the agent has categorized it as category D, and it is also able to decide that it should call the check product expiry function. So this has been decided in the pre-processing. Then it goes to the orchestration stage where it where it's able to decide that this is the action group, check product expiry action group, and it's also able to arrive at the API path, right? So it's able to find out that it has to reach out to the check expiry API path, and how it's able to find out is through the API schema that we have defined. All right, and then in our Lambda function, in the main Lambda handler, if you remember, we had written a small logic to handle the API path. So based on the API path, we are mapping the methods which we defined above, right? So check expiry, it has to call the check product expiry method. So which is what we have defined here. So that's how the execution is happening. So it calls this Lambda function, and then it's getting the data from the DynamoDB. So this happens in trace step 2, and in trace step 3, this is just presented back to us as a response. Okay, and finish. And post processing, we don't have any custom logic. So yeah, so whatever is it's able to find from the DynamoDB, it's a formatting and it's giving us as a response. So if I give some prompt which is outside the scope of the PDF and the table, so it will say that it cannot answer the question. So let's give some unrelated prompt, right? So write me an essay on um, Niagara Falls. So we don't have it in the PDF, nor of course in the DB. So let's see what it says. Sorry, I don't have enough information. So if you look at the trace, the user input is asking me to write an essay on Niagara Falls. This is not a question that can be answered by the function calling agent using the provided functions. So it has categorized it as category C, a question the agent cannot provide helpful information, right? So there is no orchestration that happens. So it just gives a message saying that I don't have enough information. So if you look here, I did not tell the agent when to call the DB or when to call the Lambda function. It itself decided. So that this is the decision making capability that I was talking about, right? So yeah, so that's how Maya was able to solve her business challenge by creating an agent in Bedrock. So that's all I had today. So in our future series, we will take this agent, we will further refine it with guardrails and so on. So stay tuned with Pauli's YouTube channel.
Awesome, awesome, amazing. Okay, thank you so much, Raji. I think for me, it's always amazing figuring out what is happening in the background because uh, majority of us are always just there typing and getting feedback. So learning all these things, all the traces that are happening, I find it really fascinating. I find it amazing, and the way uh like reading through all those PDFs within like milliseconds and giving that feedback. So yeah, this was an amazing session. I really learned a lot. I hope all the viewers learned too. Yeah, thank you so much. So yeah, tuned in for what else we can do. What
Yeah, so
else can we
yes,
do
we
here?
can
Yeah,
we can do lots. So we should explore all the features of Bedrock. So next week we
yeah,
can work on the same agent and do some customization. We'll also talk about guardrails, how we can
yeah.
control the various prompts the users can give. Yes, we should look at it.
I'm excited.
Mm.
Yeah, okay. Thank you so much.
Thank
Thank you
you.
everyone. See you in the next one, guys. Bye bye.
Bye.